want you to start this lesson by considering the answer to the questions listed on this slide. Pause the video until you have actually thought about all the answers, and then restart the video and I will run through the answers for you. So your list of key properties of metals that make them useful should include things like conductors of electricity, conductors of heat, malleable, ductile. In some cases they do not corrode very quickly, so something like aluminium and iron are useful because of that. You may have included things like their strength as well. Where do we obtain metals from? Well, the answer to that is from the Earth's crust, where they are found in an impure form within rocks. Now, an ore is a rock that contains enough of a metal or metal compounds to make it worthwhile extracting the metal from that rock. And the link between the reactivity series and the method of extraction chosen is quite simple. Metals above carbon in the reactivity series have to be extracted by electrolysis. Metals very low in the reactivity series, such as gold, silver, are found native, chemically uncombined, so no extraction is required. For metals in the middle of the reactivity series that are below carbon, you heat the metal ore, usually an oxide or sulfide, with carbon or carbon monoxide, and the carbon will reduce the metal compounds to obtain the metal. An alloy is a mixture of metals. It can include carbon as a metal here if we're talking about steels as a specific alloy of iron. And alloys are used because generally they are stronger than the metal themselves. And your diagram will look something like that you drew in year 10 when we were looking at structure and bonding. But remember, in metals themselves, the metal ions are in neat layers. Okay, layers is a key word, and if you can disrupt those layers by hammering or something like that, and they will slide over one another. Whereas in an alloy, where you have a bigger atom, or even actually a smaller one, those layers are disrupted and they will no longer slide over one another. Gold is an important example of a metal that is alloyed, simply because pure gold is far too soft. For instance, my wedding ring would have lost its shape a long time ago if it was made of pure gold, and the markings on it would have rubbed away. So most jewellery, well, pretty much all jewellery, is not made from pure gold. Pure gold is 24 karat gold. So it's the carat that's used to measure the purity of gold. How do you work out the percentage of gold in 21 karat gold? Well, that's quite straightforward. The sum is 21 over 24 times 100. You can do that on your calculators as well as I can. Second type of question you might get asked, and again this is maths really than chemistry, rather than chemistry. An alloy of gold contains 80% gold. How many carats is this? Simple, you just do 24 times 80 over 100. And that's your answer. Simple stuff really. Steel is another important alloy. It's an alloy of iron with quite often carbon in it and some other metals as well. What I want you to do is do a little bit of research, have a conversation with Mr. Google, and I want you to complete the table below. Okay, again, so you can pause the video while you work out the answers to that. One of the main problems with using many metals is that they corrode. This means they react with the environment around them. So that could be water in the environment, that could be air, oxygen in particular, or even carbon dioxide in some instances. Rusting is the specific name given to the corrosion of iron. And you should know from way back in year 9 what the conditions are needed for rusting to occur. Basically, water and oxygen. What I want you to do is answer the question, explain why the nail, etc. by pausing the video, and then I'll go through the answer. The nail in tube 1 has rusted because that tube contains both oxygen and water. The nail in tube 2 does not rust because when you boil water, you are removing the oxygen from the water. And the purpose of the oil in that diagram is to stop any further oxygen dissolving in that boiled water. So you've only got water present, no oxygen, so no rusting. In tube 3, there's oxygen present, test tube is full of air, but calcium chloride absorbs the water from that oxygen. Absorbs the water from that air. So we don't get any rusting occurring. Because corrosion is a big issue worldwide, we need to consider how you can prevent corrosion. There are two key methods. There's one, surface coating. That's things like painting, covering with plastic. And the other one is a little bit more complex, and it's called sacrificial protection. And that involves you being able to explain why, for instance, magnesium is used to prevent iron from rusting in certain circumstances. So what I want you to do is explain how each method works and give examples of each type. That should take you a little while to research, and then the only other thing I want you to do for today's lesson is complete the attached worksheet.